And then just a little introduction. So algebra is actually a way to help us describe relationships, right? And one of the way of describing a relationship is functions. So using the NROC definition, a function is a specific type of relation in which each input value has one and only one output value. If the input value is an independent value, and then the output value is known as the dependent value, so the values actually depend on each other. So that's what NROC has given us to use as our examples. So here, just a few examples. What if we had like name of senator as our input value, and then the name of the state as our output value? Do you think that's a function? Very close. So when you have one senator, right? Can a senator belong to multiple states? So let's say one is Hawaii, the other one is California. Is this possible that a senator can be um, a senator for two different states? No, it's not possible, right? So this is not possible. So because it's not possible, it means that for every senator, I'm going to put it in a different color. It means that for every senator, there is only one state. So senator can only have one state, right? So because the input value has only one output value, this actually would be a function, right? Because there's only one for a senator, it can only be a senator for one state. So that would be our explanation here. So senator equals one state. Okay, what about the opposite of it? Is it a function when you have a name of a state equals the name of a senator? Very close. So this is actually the opposite. It's no, this is not a function. The reason why is because let's say California. Okay, I'm not sure who the senators are, but California can have multiple senators. Senator number one, I'm not even sure how many senators they have, but I know for Hawaii we have about two senators. I think all of them have two senators, right? I don't know. I'm not very political. Josh, do you know how many senators each one has? But basically, a state can have multiple senators. So with that, it means that it's not, right? Because California would be known as your input value, while the senators are your output values. So do you see how it has one input values but two output values, which means that it's not a function? Is that clear so far, Kyle? So I know those actually confuse me myself, but just as a rule of thumb, when you want to see if it's a function or not, it should only have one input. Sorry, one output. Yeah. What about this last one right here? Time elapsed, where the output is the height of a tossed ball. Would that be a function? Okay, very close again. So this is actually a yes. And the reason why, and I will draw this out for you because for me, I'm a visual person myself. So I like seeing things how it's being drawn. So let's say Kyle is on top of a building, right? And you have a ball right here. And when you toss it down, sorry, this will not look like a function. My arrow will not look like a function. When you toss the ball down, it goes something like this. at a particular time. So maybe this is 2 seconds after you threw it down. This is maybe after 4 seconds you threw it down. This is after 5 seconds you threw it down. It's in a different place, so it is never in the same height of the toss ball. So that's the reason why it's a function, because when you toss a ball, right, it's not gonna stay in a specific area for more than a second or so. It's gonna be moving, constantly moving. It's not gonna freeze in midair. So that's the reason why. And then, why don't you take a guess at the last part? Do you think that the height of a ball, um, as an input, could be a function in terms of time elapsed? Okay, so I think what you meant by that is yes, they can be at the different times or something. But this, in terms of it being a function, it's not. So if I were to see a ball, right, and I were to toss it bouncing periodically, because now we're not just talking about the time, we're talking about where the height is. It can be here, it can be here, it can be here, but at the same time, the different times that ball reached that height, it's the same. So maybe these are all I don't know, maybe like 10 inches or something like that. But at the same time, it can also reach that certain ball height when it's at different times. So it can result to more than the same output. I guess it just depends on where you're looking at it. So these are just examples. Don't worry too much about it. I know they're very confusing, but we actually have numbers to show you just so that the example makes a lot more sense, because the last part for me didn't really make too much sense either. But this example actually helps me make sense of what a function is. So in terms of functions, right, these are the functions that maybe like the textbook or a computer is telling us that's an output. So I'm gonna put x values here and y values here. Okay, can just by going first, I'll do the first one, then you tell me the second, third, fourth, and fifth one. Okay, I'm gonna put the numbers where they belong. So I put -3 and then -6. Can you tell me what goes here? Good. So now we see it, right? Just by looking at this, x is actually known as our input, while the y are actually known as our output. So just by looking at this, is this a function? Okay, so let's take a look if what you said is true. So remember, for every input, you can only have one output, right? So it means that it's not supposed to have any numbers stacked. So when we have things like this, -3 is around here, and then let's say -6 is down here. So that's 1 right there. We have -2 here, and then we have -1 here. Okay, so far so good. We have 1 here, and then we also have another one, right? 1 comma 5 stacked, and then 2, and then it's also 0. So just by looking at this, do you see where 1 potentially doesn't belong in the sentence or in the graph? Do you see like any stacking or any doubles? Yeah, so here they're actually stacked right on top of each other, right? Which means that we have one which was double counted. Do you remember that idea that I had with, or the example that we had earlier with the senators? It's a senator being a senator for Hawaii and being a senator for California, right? So, and we said that this was not a function because it's counting for two outputs. Similar for this guy right here, they have the same input, which is 1, but they have different outputs, which is 0 or 5. So that's the reason why this would not be a function. Does that make sense so far? So it's a little better now, right? That we can actually see, oh, what's a function, what's not a function. So earlier it was just words and we're trying to imagine what it is. But yeah, but now it's like, okay, I think I'm starting to see it now. They're not supposed to have the same y value. They're not supposed to have the same output. So the output has to be different, or the input has to be different for every output. So this number right here, this has to be unique. Okay, what about this one? So I'm gonna put the x here and then the y's here. Again, I'll do the first one, okay? And then you tell me the second ones. So -3 and then 4. Can you tell me what goes here? Okay, -2. What about this one? 4, -1, 4. Okay, almost there. Okay, good. And last one. Good. Okay, what about this one? Do you think this is a function? Okay, so let's see it. So, good question. And then I'll answer that right after we um, graph it. So, Cal's answer is he thinks so. And yeah, and then you asked about the output. So, the first thing we do is graph it. So, we have -3 here, and then a 4. Then we have a, put 4 here. Then we have a -2 here, and then a 4, right? -1 here, and then a 4. Then last two ones we have 2 and then 3, 4. So whenever you're doing this, just because that they all have the same output values, it's still a function. Yes. And the reason why is because there's only one input. Oops. Sorry, I spelled that wrong. Because you only have one input for every output. So to answer your question, as long as this one is unique, this one does not have to be unique. So good job, Kyle. So yes, this one has to be unique. Your input values, the y values, it's still okay. And the reason being is that if I were to see if there were numbers stacked on top of each other, we can see that it's actually very unique. There was only one. The one value was here, the one value was here, 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 and here. Because of that, it means that it was only able to stay in one place. So good. So now when we're looking at domain and range, domain is actually your set of inputs, right? So how far and wide are your x values? While your range is actually how, you know, how up or how down in terms of the up and down are your y values. So that's what domain and range means. So when we're looking at these values right here, -3, -2, -1, 0, 1, and 2. When it's asking you for the domain, you actually look at your x values, right? So those are the blue arrows where I have it. Can you tell me what your domain is? So domain values means any of the x values that's included in the data set. Good. So instead of writing that, you can actually put the following. If they were to ask you, your domain is from -3 to 2, right? Because then that's where your range. I know, okay, might be a little difficult because the other one is range, but that's where your numbers are. Your numbers fall within those category, but if I use open parentheses, it means that they're not included, right? So whenever we're talking about domain and range, we always want to make sure that it's closed parentheses. This closed parentheses right here that I wrote indicates that your number includes the 3. So it's part of 3, it's part of 2, like 2 is part of your domain. So good. In terms of range, what we're actually looking at are how up or down your graphs are. So that's when you're looking at the y values. The y values here. Okay. So in terms of range, can you tell me what's our range? Good, just 5. And then those are the included ones. Good. Do you have any questions on domain and range so far? Okay, great. So have you heard of this test before, the vertical line test? Okay, sounds good. So the vertical line test is actually a commonly used test for functions. So in terms of vertical line test, there's a question here, what do you think it is? It's all of these red marks right here that's going down with the graph. What it means is that if you had like an imaginary line scanning through your graph, it should only hit one point at a time, right? So if I drew a vertical line here, it should only be 1 point. And I know it seems like the points are overlapping at the end, but it's actually not. It's just that the graph is very close to each other. But even if it was like 0.0005 difference, it's still a difference in terms of the point values. So that's the reason why this one would pass the vertical line test, right? So good. So what about this one? Do you think that the function is a vertical? Do you think that the circle is a function? Good. So it's not a function, and the reason why it's not a function is because of the vertical line test. So in the beginning, let me just go back real quick. In the beginning, I was drawing these black lines, right, to tell you that they're not supposed to have any overlapping things. So that line that we were actually drawing in the beginning is the vertical line test. We just didn't name it yet, just so that we could see it later. And then also here, when we said that this was not a function because it was overlapping. So just remember, it has that fancy term, vertical line test. So let me just go back to our current state right here. Okay, right here. So it's not a function, right? Because it's touching this part of the graph and it's also touching this part of the graph. So good. And then the last part, so the last part of our sessions are actually evaluating functions. Okay, so if you're given the following formula, given f of x is equal to 3x minus 4, find f of 5, do you know how we would be writing this equation, Kyle? Good, that's exactly the definition. So when they're telling you to evaluate the following function and then they give you a formula, that's exactly what you do. You replace x with the number that they put in here and then you solve it. So given this, f of 5 is equal to 3, 5 minus 4. Can you tell me what's 3 times 5? Perfect. Good. And then what's 15 minus 4? 11. Good. So that's actually like a really easy example, right? What about here? So what if they gave you not just a number, but they also have a variable with it? What do we do now? Good, so you solve it with h still. So even if you have a variable, it doesn't matter, right? They could give you a whole equation to put in the parentheses. If it's telling you to evaluate a certain thing given f of something else in the parentheses, you replace x with what's on the parentheses or what's in the parentheses. So with that, it would actually be written as, can you tell me what it would be written as? Yay, good. So f of h plus 1 is equal to 4h plus 1 plus 1. And when you do that, you distribute the 4 in both the 1 and the h. So it becomes 4h plus 4 plus 1, which is, what's our final answer? Good, 4h plus 5. And then I know sometimes what drives students crazy is that it doesn't seem to be simplified because there's still the plus button or the plus sign, but it's okay because the reason why it is simplified is because you combined like terms already. These are the only two that were alike, and 4h could not be combined with anything, so your final answer is still an equation. So I know it's like, oh, but I started with a equation, do I still end with it? The answer is yes, if that's what you're trying to do in terms of what they had given you. So that's actually the last question. Most of the time, the functions are used when they give you like evaluate the following or is it a function given that. but these are commonly used in higher level math. Um, I've seen this a lot in algebra. I've seen this a lot in calculus. So as far as calculus, you actually still have to do something like this. Very similar, especially when you're looking for limits. Um, oh, these are actually also used. So when are the practical applications, right? It, it's used when they're asking you to find for the length and width given the area of something. So for example, if I told you that I want to make a border and then I gave you the length to be um, 5x or something, and then the width is equal to 3x plus 1. When you're solving for like the values of x and the values or the length and width, these actually come in handy. The reason why is because the first thing that you would do, so I'm not sure if you would have to take this later on, but I mean just an introduction to something where you might have practical use for it. You can find the area. Oh, and then of course they have to tell you the area of the items just so that you can solve it. They'll tell you the area, length times width, and then you will have the perimeter, which is 2L plus width. And then by doing the substitution that we're doing right now, you should be able to solve for x this way too. So this is the process of finding variables through substitution and also finding variables through elimination. So that's where functions come in handy. I'm not sure if you've learned it before, but I'm sure you don't need it for the AccuPlacer just yet. We have a lot of time. One of the reasons why we left this many time also for the last session is because we've gone through 9 skill sets, right? Or just the overview. Sorry. At this point, do you have any questions for either myself or Josh? About any. So just in case, because usually what we like to do is that at the end of the lessons, especially because this is our last lessons, right? We can't really ask you, oh, hey, Kyle, did you have any questions with the other ones? You can ask us about anything as much as we can. We'll try to answer it. So if it's about college, if it's about the AccuPlacer, if it's about factoring, or any of the other lessons that you would like to go over, we reserve the last 30 minutes just to go over them. And then of course just let you know about our additional resources. But other than that, it's mainly to go over with what you need help with and any other thing that we can ensure that your experience with the skills webinar was as successful as we hoped it would have been. Oh, and then the links I will send you after this one. Sorry, I forgot to send a reminder to myself, but I will send you all of the ones that I need to send you, including today's one. Oh, okay, there was a lesson you want to try. Let's see. Well, you can always email us too, and then you can email me. Let me know if you need like help with a specific topic. Also, like I said, our online learning academy, this is actually where we house a lot of our tutors. So if you like this platform that we're using, we use the same platform. It's called Blackboard Collaborate. The only difference is we're under a different virtual office right now. But if you were to visit this link and then see that it's the manoa.hawaii.edu, our calendar is actually also on it. I didn't know that our calendar was on it until recently. If you look, you can see who's currently working at that day. So I don't tutor anymore, so you wouldn't find my name in it. But Josh is he's an amazing tutor, and working with him, I think you will like it. He actually tutors one-to-one with our students. So if that's another possibility that you like, working with Josh or any other tutors and you want to schedule tutor, just email me and then I can set you up with our tutor. This one right here, the New Mexico State University Learning Lab. There's also Khan Academy and also Hippocampus. But other than that, we're mainly just OLA, Online Learning Academy, and I'm not sure if you've heard of it, but we also have EdREady. So EdREady actually is where we got the information here. So all the credits goes to NROC and EdREady. And these information right here allows students to help for their AccuPlacer preparation. And a lot of the students in the past were able to place in college level math as well as high as calculus through this preparation. So if that's something you're interested in, let me know and I can send you a code. Just also remind me what high or college you're planning on going to, either Windward or Maui College or any of the community colleges you're going to. I can send you that code. So it's called EdREady, and then we can send you all that information. It's free also to use. It's free for any students to use. And you also are assigned a cyber mentor who checks in on your weekly or every other week your progress, just to make sure that if you have any questions, you can let them know. So those are also one of our online tutors. But other than that, you know our contact information. You have my email, and then also our main email, ola@hawaii.edu.